In this lecture, we're going to take a look at how we can manage some competing parallel executions where our animation potentially wants to move our worker, but we also want to move them to the edge of the building. We'll start here in our behavior tree. So far, this branch on the right is what we've been using for all of our animations. But there's not really a clear way with how we've structured this right side to join back up with what's happening on the left side, because we want this block over here on the right to continue repeating until this thing on the left has completed. If we move the left branch over a little bit, we can see we're going to want to do a couple more things after we're done. In fact, we really want something like this with our translate position to somewhere on the edge of our building. If we set it up with just self moves to target location at 1 speed, that doesn't quite give us what we want because the target location is going to be the center of the building. So we need a new node in between these two that would set the target location. And we're also going to need to do something to stop this repeat while from happening because we don't want to be trying to translate in 2 different locations. We'll tackle one problem at a time. So let's make a new node that will pick a target location based on the collider. We'll call it pick closest point on collider, and we'll leave that in the default category of action. If we click next, what's the data that we think we need here? We need that target location, the point that we want to check from, and the thing that we want to check for collider on. I think the story set target location to the closest point to target on collider makes a lot of sense, where both target and collider can be game objects. Let's create that in our scripts behavior folder. That'll open up VS Code, but we'll stay here in the behavior tree. Let's move that node into our sequence between set is building on self to false and moving to that target location. We'll set up target as self, and the collider should be that building under construction. Now, what we don't want to do is have this self moves to target location going while we're still doing stuff on the right. So we need a way to cancel this so we don't keep going. Our repeat while has a condition stating that it will continue to repeat until the command is not equal to base building, which was fine, but we want to abort doing that repeat basically right after we have completed building. So we might be able to change this to say, instead of command is equal to build building, what if we checked the building under construction is not equal to null or an empty object? Well, that'd be good. We just need to set that value after we've gathered our closest point right here. So let's set a variable value. Let's set the building under construction to be a null value. The only problem there is if we're, let's say, waiting, we're still going to hit these next 2 sets of nodes. So we need to add in a new flow control node, an abort if. Let's say abort if, assign condition, variable conditions, and we could really probably use either variable value changed or variable comparison. I think variable value changed is more simple. So if the building under construction has changed, we can abort that whole tree, take that run in parallel straight into the abort if into repeat while. Let's do a little cleanup. Shift A on the run in parallel node, then again on the abort if. Now we'll keep doing whatever we were doing before, but as soon as we hit this node, we're going to abort execution of whatever's happening on the right over here and move on to moving, which should get us out of all this other stuff. Which means we might want to just logically, right before we start moving, set our is building to false, because we know this is going to trigger this abort if and we don't want any weird behavior from that other tree. This is looking pretty good, but don't forget, we need to make this choosing the closest point on the target. So we can hop over into VS Code, and I know you felt it coming. This lecture's challenge is to implement this node. So go ahead, implement that pick closest point on collider action, where we'll output the closest point on the collider to the target location. Pause the video, implement that. Once you've got it working, I'll see you right back here. All right, welcome back. Let's jump right into VS Code. In our pick closest point on collider action, we just need to put that in our namespace, GameDevTV, RTS behavior. We don't need onEnd or onUpdate, and we've got all the variables we already need, so we just need to do some checking first. We need the target value to not be null, so let's check if target value equals null, or the collider value is null, or not collider value.tryGetComponent out collider. If any of those return true, we want to fail. We don't have the information we need here. Otherwise, we're going to return success. And the only thing we need to do here is set the target location value to the collider.closest point, providing the target value transform position. That's all we were looking for here. We've already done similar things before, so I hope you're able to put it all together to make this action. If we come back over into Unity, we should have everything we need. Let's come over into the game view, click play, select that worker, tell them to build a command post. We'll watch them build, so we'll do a little fast forwarding so you don't have to sit here and wait forever for it. As we slow down to normal speed, here we go, entering our new behavior. Not quite what we were expecting, and if you're watching closely, the NavMesh agent component is enabled constantly, and that's why we had that jitter over here on the right side. As the command post was coming up, eventually our NavMesh obstacle came up, which made our NavMesh agent no longer able to find a location on the NavMesh, so they teleported to the edge. Then we saw the translate position to the right spot, then the agent became enabled again, and that's why we saw it teleport. We can approach solving this in a few ways, but this is actually a symptom of a larger problem that we have. We haven't had our NavMesh obstacle placed properly, and so we've been working our way around a different problem, where let's just make this worker build a new command post. We can see that obstacle is not carving the NavMesh at all, and this worker has their agent enabled. Really, whenever they start building, this agent should be disabled. They should move around and there should already be a location carved. I don't think we're going to be able to get all of that solved in this lecture, so why don't we tackle that problem in the next one? When you're ready to solve this, I'll see you over there.